Good morning, students. Dr. Math speaking again here. How are you feeling? Well, I'm gonna do today the last of the examples of solving exponential equations, and here we're gonna do this equation. We're gonna solve this equation, which has a different base of what we have seen so far. You see that? We have an e in here, and that's something weird because we usually have as a base a number like 20 to the power of 10x, or we have 10 as a base, or we have 17 as a base, or 5 as a base. Well, here we have e as a base, which is something strange, new, that we have not seen before. So let me introduce you to this number. In math, we have numbers that they have for whatever reason they have they're really important. They're numbers that they mean something. So you might remember pi. Pi means something, right? It has but it has a meaning, right? When it comes to the circle. While e, it also has a meaning, but the meaning of e, it's more deep. It doesn't have to do with simple things like pi, but this is more complex. We cannot explain now why e is so important, but at least we can tell you that e, which shows up in math all the time, but more upper math. So E, it's more or less 2.71, and it keeps going. It's an irrational number like pi, and it keeps going forever. Okay? So instead of writing all these numbers, we just write E. This number is so important that actually in the calculator we have a button that's called natural log. See it in here? Which is actually the log base e. Okay, good. Let's try to solve now this equation. So remember this, that we want to have an exponential equation that looks like this, that has a base, the exponent, and everything else is on the other side. So what is annoying us in here to have an exponential equation like this, where there's only the base and the exponent? If we see, where's Mick? Where's Mick today? Oh, Mick, you came late to class. Where were you? The hallway? Oh, I'm sorry, Mr. Burrell. I went to the restroom. Okay. Please don't put me tardy. Yeah, don't worry. Okay. So now, as I was saying here, base, exponent, right? So Mick, what in here we must get rid of to have something like this? The 9? Yes, the 9. So this 9 must go to the other side. Remember, if we want to cancel this 9, we need to subtract 9 both sides, correct? So if we do that, this 9, it's actually flying to the other side of the equation as a negative. So we're going to have e to the power of m plus 3 equals 33, and then minus 9, right? So 33 minus 9 is 24, isn't it? So e to the m plus 3 equals 24. Okay, it's 10 less, which would be 23 plus 1 more. Okay, so 24. Now, next thing that we have to do is we have to apply this formula, right? Remember, the exponent flies to the beginning, right? And then we're gonna write log. So we're gonna write m plus 3, the beginning, and then log base e of 24, right? That's how we write it. Now, just for you to know that actually this, instead of writing it like this, we call it natural log, and we can rewrite it as this, natural log of 24. Okay, same thing. So that means that when we're solving this with the equation, we have two choices. We can go directly. Let me see if you see it, guys. We can go directly for natural log, which is here, right? Natural log of 24, which is 3.17. Or we can also just do the classic way we have been doing before. So alpha f2 log base, and then on the calculator we have the e number in here. See that in the division? And just on top of the division, the blue one, that's the e. So we do then second e. Here we go. That's base e, and then just the number 24. We're gonna get exactly the same thing, same answer. Okay, 3.17. We can put, well, actually, if we're gonna round it, we can round it, right? Because this is an 8, this should be also an 8. That would be more accurate, okay? More precise. Okay, that's it for today. Have a nice day.